our last generation machine. The new one, that is the reason why I'm here, is even faster. So we can do about 680 millimeters per second, which is double the speed of our last generation machine. But that isn't really the cool thing.
Hello everyone, and welcome to Advanced Engineering Talks, a podcast created by the Advanced Engineering team. A Talks brings together some of the newest and most innovative minds in engineering and manufacturing to help better the future for our industry. We hope you enjoy the series.
Hello and welcome everybody. Jeremy Whittingham here again, interviewing on behalf of Advanced Engineering. I'm once again delighted to bring you another Advanced Engineering Talks podcast where innovation never sleeps. With me today, I'm delighted to say, are a couple of prime movers who are behind what's been dubbed the UK's fastest 3D printer, all of which started, of course, out of a young man's bedroom and his work in that bedroom. That young person is Jacob Lord. He's the founder of Construct 3D. Jacob, welcome. It's lovely to have you with us.
Thank you very much. It's been an experience getting here, but it's been fun.
Oh,
I wouldn't change it for the world. Yeah.
Well, you can touch on that again in a minute. Then that sounds interesting. Nigel, we also have, of course, delighted to say, joining us though is Nigel Robinson from AM Futures. That's your own business as a consultant and reseller, of course, Nigel, and you work with Jacob and the business as part of your overall mission to develop and enable additive manufacturing across the manufacturing supply chain. So welcome also, Nigel.
Thank you very much. Yeah, no, thank you for having us here. It's a privilege.
Great. Well, so I've got to start. Come on, guys. Just how fast is this printer? Can you give us an idea?
Go for it, Jacob.
I don't think you're ready for this. So I'll give you a bit of background because everything needs to be compared. Comparison is the thief of joy, and boy, does this bring me a lot of joy. So traditional printers, you can categorize them in generations. What most of the industry sits in, as well as a lot of the older style of consumer machines, are in generation 3, where their print speeds are at 60 to maybe 80 millimeters per second. They can tend to push maybe half a kilo per day of material. We then launched a machine, and that already was a lot faster. So we were pushing 300 millimeters per second per day, and we were doing about 1 to 2 kilos per day of material. So that is generation 4. And the industry has started to catch up on that. We've got a load of new consumer machines hitting the market with those speeds. And there's a few industrial machines that are catching up because obviously, as we all know, the industrial market is sluggish. They tend to have a lot more mass behind their developments. But that's our last generation machine. The new one, that is the reason why I'm here, is even faster. So we can do about 680 millimeters per second, which is double the speed of our last generation machine. But that isn't really the cool thing, because print speed you can kind of fake. You can lower the layer heights, you can do a lot to make the printer move faster without printing faster. What we've done is we focused on flow rate. So we can actually push up to 8 kilos per day of flow rate. And that is next generation printing, because now you can print quite big objects in only a few hours, where normally it would take 24 to 48 hours to do the same on comparatively slower machines. But that's what I do. And that's the speed.
Wow. That sounds incredibly impressive. And so it sounds like you're going for obviously both, did you say consumer and industrial sectors? Is that right? And I'm getting the impression the consumer ones may be more, more development there in terms of demand. Is that right?
You'll be surprised. So what ended up happening was we launched with a consumer machine to start with. And it's a gorgeous machine. It's got bamboo side panels. It looks great because I have a personal pet peeve for just black machines that look the same as everyone else's. But we launched that machine. It was about 3 years ago we went public with it. And the biggest complaint we got from both sides of industry and consumer was industry thought it was too cheap for the performance. They thought there was something shady about it. And on the consumer side, they thought it was too good for a consumer machine. So we ended up selling a lot more to the industrial side. And it was almost like they believed the marketing was fake. because the numbers were just that good. So we ended up getting like third-party validation and everything.
Right, I
But
was going to say,
from
yeah.
that, we decided like, hell, if people are telling us this is an industrial grade machine when it wasn't designed to be, what happens if we make an industrial grade machine? Like we can pull all the stops. Like we made caveats for the consumer machine that didn't make sense for industry. So let's pull every plug. Let's turn everything to 11. Let's put those motors to 100% load. Let's make the hot end actually get hot and work as hard as it physically can. And from that, we've ended up making a machine that literally is 12 times faster than some industrial machines on the market today. And I'm talking new machines. So that's us.
It sounds very, the way you say turn it up to 11 there, it's pertinent with the Spinal Tap movie being re-released. Let's say, yeah. You may not have seen that first time round, but that's
I haven't. I'm looking forward to the remake, though. Actually. I'm very much looking forward to the remake.
But turning up their amps up to 11 was the big thing on that. But that sounds really, really interesting, though. Yeah. So at the moment, you think you're concentrating more on the industrial now supply chain side of things then as a result of that? Yeah.
So originally when we did the consumer machine, it's because the consumer machines were getting stagnant very quickly. Right. They were just like, they were eating themselves alive. They were cloning each other because there wasn't much development. We made our machine, industry caught up. And again, we've noticed the industrial sector is just massively stagnant in terms of their development. Like they're focusing on soft cells and rebuilding the same machines, but slightly more efficient. Whereas because we've been fighting in the consumer space, which is a lot more aggressive, like they are very, nickel and diming isn't the right word, but they are trying to eke out every millisecond of performance from every machine to make their sales. The industrial side doesn't have that. They are big enough that they can be slower. So us going from one quality to another was actually quite an easy change. We already know how to make a machine move a lot faster whilst keeping the same quality. We've actually got CT scanned parts and third-party validation to qualify that we make industrial class machinery. So we went from that to the industrial class, and we focused on all the pain points because I don't like maintaining machines. I don't like machines that are slow. So we took all those pain points and we just fixed them because they're not massively difficult to fix if you actually listen to the users, and then put it in one machine. And we've kind of made the holy grail of high performance, high speed without a loss in quality, because a lot of these machines, when you speed them up, they tend to dip the quality a bit. But we focused on that. And it's honestly been really scary to see the machine in person because you don't expect how fast it moves.
Wow. Now this incredible speed that you're talking about there, have there been challenges with that in terms of overheating of anything or challenges that you've had to go through? I think you might have touched on that a bit, but it sounds like you will have had to perhaps do quite a bit of testing in that respect. Is that right?
Oh, everything. I don't actually even classify the company as a 3D printing manufacturing company. I class it as a 3D printing research company because 90% of what we do is researching how to make something better. The applying it to the machine part is just put it into production. So literally, like, to go faster, you have to do stuff like resonance compensation. You have to measure the internal resonance of the machine to then cancel it in the code as it's printing so you don't get vibration like deviation. Or you have to worry about a feature called pressure advance, which is as you melt your plastic, you basically have a little crucible of liquid plastic, and when you push new material in, it doesn't immediately come out of the tip. So you have to like simulate the internal behavior of plastic as it's coming out the nozzle to guarantee the quality as it comes out. And then you've got others like maintenance schedules where things that move faster break down faster, so you've got to make sure it doesn't break down, and if it does, you've got to make it maintainable, because the last thing anyone wants is a machine that breaks and then it takes 2 to 3 weeks to get a service engineer out. No, if your machine is not up and running in 10 minutes, we've done something wrong. And that's on the design side, because everything should be user serviceable if they want to.
Right, yeah. Interesting, yeah. And what I suppose, a lot of these things that you've had to do, have you had to sort of work with other partners, and a lot of this sounds as if is development that costs quite a lot of money. And have you had investment to help with doing all this, or is it a lot of it being already on your own?
Oh, that's actually a really interesting one because I don't actually classify what we do as new tech. It's just
Mm,
reutilizing technology from different sectors. So
mm,
noise cancelling headphones, for example, this is one I love coming to. The end goal is a feature called Input Shaper, which people can Google and find out.
mm.
But it's basically noise cancelling headphone tech. You measure the resonance of a part, you just apply the opposite resonance as it gets to the corner of a
Right.
machine, and it cancels the resonance. So if you imagine your printer is moving up and then to the left, when it gets to the top, if you suddenly change direction, you end up with this wibble as the entire printer flexes. And you really don't want that because that wibble shows up in the surface quality of your parts. It drops the tolerance, it makes those parts unusable. So most industry,
Mm.
they just slow the speeds down. If you don't do it as aggressively, you don't get the wibble,
Right.
but you're slowing the printer down. That's not
Yeah.
kind of what we want. So what we do
No.
is, as you get to the corner, we do a micro pulse of movement just before it hits the corner. So as it moves the other direction, that micro pulse is the opposite frequency of that wibble, so it
It
cancels out.
cancels it out. Wow,
Yep.
that's really interesting. Yeah, yeah.
But it's just little
And I
things.
suppose,
Like there's loads of
yeah.
others, from the movement kinematic system to the motors to just like how the belts are driven, because we have to use really high grade belts, otherwise it flexes and it twists. Like
Yeah.
everything is a aspect that builds speed, and your printer
Mm,
can
mm.
only go as fast as the weakest part.
Yeah, of course. Yeah, yeah. No, I mean, it's interesting, the speed is of the essence, and also the reliability, isn't it? Because
Mm.
certainly we hear such a lot from our, attendees at advanced engineering is, they're always looking for new technologies that help to make that process quicker, so that they can save on costs and increase efficiencies. And I mean, the whole thing with when you launched this, I think you launched it at TCT, didn't you, in 23?
Mm.
And TCT stands for time compression technologies, so that's what everybody's looking for, aren't they? So I guess it's interesting that you've had a little bit of almost skepticism, isn't it? It can't really be
Yep.
this fast, and yet do this and so on. So but you've obviously been doing quite a lot of changing of minds on that, I guess, by the sounds of it.
It was really enlightening. The first time we did TCT, we had I can't remember who it was now. It
Mm.
was I think it was Professor Kailash from Warwick Manufacturing Group.
Oh yeah.
Came down, saw our machine, saw the tech spec that we were advertising, and this is before we had validation. It was just me, my mum. She woke me up and was like, "Hey, we're going to TCT and we're exhibiting in 10 weeks. Go!" And we took the first prototype and we showed it off, and we were like, "It does this speed and it does this." We didn't make any claims. We just said these are the guarantees that we can promise. And Professor Kailash came along, saw it in person, and was like, "There's no way it's doing that. You must be lying in some way because it is moving faster than a £250,000 printer on the stall across from you." So
Mm.
they took a machine. It was supposed to be with them for 4 days, and instead it was with them for, I think it was 4 weeks, where they just ran it through all the paces. They tested it against like a dozen different machines. There's actually a white paper, which is what we like. We like publicizing all the research that happens,
Yeah,
good and
sure.
bad. And long and short of it was Neil Jeffrey in the Warwick Manufacturing like test lab turned the machine on. Was like, "Oh yeah, we'll see if the machine does what you say it does." And we printed just a little benchy boat, and he stood there the entire time it printed in 22 minutes, which normally would take 2 hours from what he's used to. And he just stood there going like, "There's no way it's this fast." And then after 22 minutes, he popped the part off. It was like, it's a part. It looks perfect. And that
Mm.
was where our story really started. And now we're coming 3 years into the future, and we've got a new industrial machine, which is even faster.
And so what is your stage now, if you like, since all of that time? Well, not that long, obviously, but in terms of manufacturing more of these printers, and are you at a sort of cusp of now wanting to produce more of the machines themselves? And what are your plans for that, and how is that working?
Oh, that's the $1 million question right there. So the short answer is yeah. Everybody wants to make more. Like, who
Yeah.
doesn't? But it's been scary because so we've already got a factory. We've got the factory all set up. It's all like mature and everything. But as we release this new industrial machine, like we're considering getting a second factory. Like,
Really?
I did not expect to be saying that within 3 years of launching that we might have to get two factories to
where are
start
they
making
based?
machines. In Lincoln at the moment. So they're literally a UK-made product in Lincoln. It uses over 80% like UK-based components, and the only times we don't use UK-based is when it doesn't make feasible sense. Because to be honest, aluminium's the same no matter where you get it from. So we can get it from the UK, but then we charge you more, and we don't want to do that. We want to make it a good deal. Other than that, like every hero component's British designed, British manufactured. It's fantastic.
Yeah, that's a great story. Yeah. But I guess again, you've had to you must have had some investment and or you're looking perhaps for investment, are you, to cross the valley of death, as it's often called, but you know, to commercialize further. Is that where you are at the moment as well? You're looking for
a little bit. So far it's been natural growth. So we've done natural growth to get to where we are. We started small, literally me, a garage, a shed, 2 CNC machines, and a hope and a dream. I quickly got evicted from the living room where I was building machines. We got a factory unit and we're doing it all in there. But it's all been natural growth. It's been slow. I will admit it's been slow because it's been natural. We've not done a lot on the marketing. We've not done on everything. Sure. But we are open to investors. And the key thing that we want from an investor isn't, oh, I'm going to make you loads of money and that's it. Because they tend not to be the right investors for this industry. We need to find people that can provide more than just money, because money is actually kind of easy to come by. We can get a loan if we really needed to. Like, we're already pre-approved for like a 10 million quid loan. I don't need it. I need the black books. I need the knowledge. I need somebody to be able to tell us what we're doing incorrectly or what we're doing suboptimally. So far we've had a couple people come by and they weren't right for the business because one of them wanted to like destroy the brand and ruin what was best about the printers, which is user repairability, reliability, the quality and the ethos. Like, we didn't want to cut corners to earn more money. We'd rather have a slightly more expensive machine and guarantee it's the best quality we can provide. So those
people are prepared to
we're
pay
not interested.
higher for that. Yeah.
I mean, the biggest complaint, and actually I'll throw it over to Nigel and you. What's the biggest complaint you've heard in 3D printers so far?
Reliability is the biggest thing, and reproducibility is the two biggest things that I get over the last 10 plus years or whatever. But interesting. Sorry, I was going to say, Jeremy, you were then just talking about the investor side of things, and what we've got to be very careful of with Construct 3D, and Therese, who's sort of like the boss of this operation, allowing Jacob to do the more technical side is taking that right balance. So Jacob says, we're more of a research company. That's very true, and you've got to have that as your heart, your DNA, when you're looking for investors, that they recognize that and they don't want to stifle that. But what we've got also balance with is but to enable that and to enable that further investment in innovation, we need the commercial, solid marketing, selling machines, understanding the marketplace as well, so we can tie the two together and then grow the business that way. So hence why I'm sort of here as well is on the commercial side. So Jacob will say we're a research business, and I'll say no, you're not. You're selling machines. The research is an enabler to sell machines. So I get to the boring bit of being the guy that we also got to make money. Let's make money. Which is sometimes people don't want to hear that, but it's a very true fact that we've got to do that as well. But it's a privilege working with Jacob, and you just feel the excitement and you feel the energy when listening to him about the story, about the vision, and what Jacob isn't saying about is where the company's going to, is everything that he's got in the pipeline. His mind's going at 1,000 miles an hour of what could be possible with other materials going into the metal side and other things like that, the company wants to get into on that side as well.
Yeah, I was going to ask about that actually, because what sort of materials are you using at the moment? In terms of what you're creating.
At the moment, it's polymer. So
yes,
we in particular, we don't focus on peak, pec, and ultim because there's a lot of caveats just to make that possible. And to be honest, most of the printers in the market that say they can print peak, pec, and ultim can't print peak, pec, and ultim. Just putting that out there. So we focus on everything below that. So if it melts under 350 degrees, we focus on that. So polycarbonates, carbon fiber nylons, ABSs, PLAs, like pretty much anything that melts under that temperature is what we focus on, and we focus on that very well. We are slowly getting into other aspects, as Nigel has alluded to. So we've got a plan for introducing ourselves to the metal 3D printing world with a very interesting and quite cost-effective way to get into metal AM without a lot of the risk factors that come into metal AM. And we've got other ways to push the polymer side even further that a lot of the industry aren't ready for. Like, we are planning a meter per second printer for polymer. I won't go into more than that because the technology behind that is very special. But there is a upgrade path for current machines to keep getting faster and printing faster.
Yeah.
So come to Advanced Engineering 2026.
Yeah.
Then you might see the launch of that machine.
Okay. That could be really interesting. Yeah. And of course, that's another thing, I suppose, that has been said about additive manufacturing, I guess, is cost and the faster that you can produce 100%. Things, and you could do higher volumes and reduce unit cost. That's the real way forward, isn't it? I think because I've got the impression that additive manufacturing has been around for quite a while now. There's not been too many kind of game-changing developments in that area about them doing higher volume and higher runs because of the relative costs, perhaps. But something like what you're talking about here could perhaps be that kind of game changer. I don't know, but
see, that's the thing, is there has been those developments. It's just nobody's picked up on it. And what we do is most of my job actually is just pure like exploratory research. Like, I will go and I will find that nugget of technology that everybody has looked past and ignored and go, hey, this makes a lot of sense. Let's put it in a machine and see how it works. Like, for example, one of the biggest changes in the industry that no industrial machine has done yet isn't even on the printers. It's on the material side. So there's materials hitting the market on the consumer side of all places, which are PPS, PPA, and PPU. They are straight up aluminium replacement, like high performance engineering polymers that don't need a 200-degree heated chamber to print. They are kind of like a mixed way between a thermoplastic and a thermosetting plastic, and they are insanely high performance, and all the industrial machines have forgotten it exists. It's not a new material. It's an old material. It's just nobody's processed it into a filament. So we've got print profiles for that material. So you don't need to go to Ultim that costs like 200 to 500 quid a kilo. You can go to a much more cost-effective polymer that does the same job. And it prints easier. There's less post-processing steps. It's literally you print it, you're done. You don't need to thermally post-process it, so you save time as well. Like, it's those sort of like developments that I really like to focus on, because they provide solutions to people where normally they'd buy dedicated machines for. And we can process it all on the same machine that we're showing off at Advanced Engineering. So I'm really happy with that.
Yeah. I think from the additive side of things, I would probably disagree a little bit. I think the industry has evolved in different directions,
different ways, right?
And different ways. So, I always use the analogy of the automotive side, and I class motorsport within that automotive side. So back in the day, I worked at 3T. From the automotive sector, you're really talking about F1. That was the only one that was really investing it in that sort of sector. And as we've sort of gone through the last 10 years, it's now been adopted into hypercars where, 100, 150 cars are then being, taken on, prestige cars, going to sports cars, and so forth. So, and the reason why that's happening is the piece part price is coming down. Is it coming down fast enough? Absolutely not. And there's ways in which you try and do this, but it's always it comes down not so much to the material cost, but to the machine, because the machine and time is the biggest factor when it comes to a cost of a part. So when we're talking about Construct 3D, having a cost-effective platform and a fast platform, it's a win, tick, tick, tick. If we're talking about other brands I represent as well, and I like to think I have brands that solves various different challenges where additive can be applied, from large format robotic arms to very large metal DMLS parts and so forth. We try and get the platform being as cheap as possible, so then it reflects on the piece part price. And I think that's where the industry has gone. And then the other factors that the industry has gone at is standards as well, which I know we're not going to talk about standards, but
oh, come on, I love
standards. No, that'll just drain everyone. That'll just drain all the audience. Everyone will leave, press the leave button straight away. But ASTM has done a fantastic job with standards. I know they're over in I think they're in Vegas at the moment at one of their conventions talking about DED standards, which is all right for some. But but they've done a huge amount of work, invested a lot of money to create standards. Again, another enabler. So when you talk about automotive and other sectors as well, but taking from our automotive sectors, when I speak to customers, they don't talk about how what do they need to have in place. I just point to standards now, which 10 years ago I couldn't even dreamt to have done that. So the industry has evolved in a long time, and as I say, the costing is getting cheaper. Print farms as well is coming online. Jacob has his own print farm to demonstrate how you can link up printers. So again, it's all about that costings on that side. And companies like Midland 3D has literally brought their business up on print farming and enabled then the rest of the business to grow.
Yeah. Well, that was going to be my next question. Actually, probably my final roundup question is, I think you've covered it quite a bit in terms of what are your thoughts about the development of additive manufacturing in the future, in terms of producing things. Is it going to be more used in earlier on design, prototyping, low volume, or could you see a time when it was really manufacturing quite high volume stuff?
Oh, I've got such a contentious view on this because again, everybody's ignoring the signs, and it doesn't take a genius to see them once you know what you're looking for. So, for example, let's just talk AI, because that's the big topic everybody hates talking about at the moment. All CAD design is fancy math. That's all it is. It's just fancy math. It's just, you want a box, it's just a couple of points, you know what it's doing. AI is already doing advanced programming. It does outshine most like average programmers. I think it's like 89% and 92% of the way there to being like perfect level AI. That is great for programming, but it's a sign. It's a sign that it's going to slowly trickle down into other math-based domains, like design. And once AI is on design, I'm going to ignore the fact that it's going to affect like designers as a job, but it's going to allow businesses to have infinite design at their fingertips. Like, take shoes, for example. You could literally just get an AI nowadays to go, oh, we have a base design. Let's modify it for every single person so it's a perfect fit for their foot size. Because everyone's foot is slightly different. You don't have to have generic sizing anymore. You can have bespoke sizing. And it's the same with every other part. And the only industry that is really capable of keeping up to date with infinite design is a machine that doesn't have tooling costs, which are 3D printers. An injection mold, you have to make a mold every time you want to do something, and the quantities are insanely high. Whereas a 3D printer, you just give it the new file and you tell it to go and run with it, and then it will pop the part out.
Right.
So I definitely see like additive, even as it stays at the moment, will keep growing because the world of design is changing. Let alone the fact that as machines get faster, as materials become more available, especially a lot of these meta materials and really interesting stuff like foams that you can print out of these machines to metal infused, even like radiation blocking materials are available on the market at the moment. That is where the material side is going. But now the machines need to keep up. So as they get faster and faster, that industry is just going to grow more and more and more, because you're going to be able to get custom, uniquely designed, hyper optimized, low material waste. Like it is a inevitability that a lot will become that. Not always though. Like there is still a place for injection molding, for blow forming, for vacuum forming. Like all of that does have its place. Or like gigacasting. Like you can't beat the efficiency of gigacasting, but you can get really damn close when you're doing smaller quantities with additive. Like hell, all jet engines and rocket engines nowadays are additively made. Like you cannot really make traditional rocket engines anymore because they're not cost effective for the manufacturing pipeline. So we're already seeing it on the high ends of engineering, and as those pieces of equipment become cheaper, and as the equipment becomes faster and more available and easier to use and less finicky, you're going to see the bottom end starting to creep up as well, where you are going to see bits in cars. Like, what was it?
Yes.
Nigel, you might know of this. Was it Ford who just did a 3D print service where they give you a load of CAD models and you can make the parts for your car? I think it is Ford.
Okay.
Yeah, I think it's Ford.
There's a couple.
Yeah.
And we're starting to see that
BMW
really
do a
kick
similar
in.
sort of thing as well. They're at the forefront. It's localized manufacturing, isn't it? That's what's is going by. But you know, I think the world of additive manufacturing, and this is where it can be applied in so many circumstances. You asked the question: is it going to be in prototype? Is it going to be in production? It's going to be in both.
Of course,
but it's got to make sense. But it's not going to be in conflict to everything. Certain sectors are going to improve composite tooling. Somebody said to me the other day, I said, oh, we're a bit rivals, aren't we? And I said, no, we're not. I said, composite tooling will always be required for composite composites, composite tooling, though, that can be made from additive. And that is working with companies to understand where does additive fit to solve a challenge, and therefore can be produced in a quicker, more efficient, cost-effective lead time. But the one thing I love about additive manufacturing, 3D printing, whatever you call it, how many industries, how many sectors is when little Billy and Sarah and a little Jacob in his bedroom can start 3D printing things at 8, 9, 10 years old, develop, and then have a career out of it, and then for whatever sector you want to do. If you want to go to space, if you want to drive Formula One cars and be in the engineering team there, if you want to be in medical, medical's using 3D printing.
Yeah, very much so.
So you have that foundation and you can literally go in different directions with it. That's what I love about it. And I love the fact that these stories, like Jacob was saying, I started this in my bedroom with the vision of where I wanted to go. And then suddenly, this has got they've got a fantastic product. But not just that product, it's then how it's going to grow into the next generation, the one after that, and it'll have its niche. and all these different technologies that comes under the 3D printing additive manufacturing umbrella will all have niches for whatever the technology will actually be, whether it be FDM or DD or DMLS or whatever it will be.
Yeah, well, amazing. Yeah, what can I say? Time is coming to an end, I'm afraid, both. But so probably going to have to wrap things up there. But it's been a great conversation, and what you're doing is, I love the combination of what you're doing, Jacob, as well, and what you're there to do, Nigel, as sort of touching on the development and the market and the commercial side of things. And it sounds
it's as Nigel said to me quite early on, is I am not a salesperson. I do not have the mind for it. I have the technical expertise. And hell, Nigel has told me enough times I suck at marketing. I absolutely suck at it. I can have this golden apple and I'll just be like, oh, it's just a regular apple. Nobody cares. And I've just got like the golden goose giving all of the eggs. I'm like, give them away. That's me. Nigel makes the commercial side possible.
Right. Well, I mean, you know, again, you're a great UK story of what the UK is quite good at, you know, or is innovation. Strong at, is you know, innovation, invention,
100%,
world-class level of that, of 100%. IP knowledge. And, you know, we'd like to think that, you know, what we try and encourage at the Advanced Engineering Show is to bring that out more, to expose the potential opportunities for it to be ultimately out there and commercialized and used, and also ultimately help grow the economy, you know, which is what it should be all about for UK PLC, you know, and so on. So yeah, it's
and we're looking forward to launching the Construct 2 at Advanced Engineering, and if you're there on the first day, 10 o'clock on the AM Future stand.
Great.
So it'll be an unveiling and showing, as you said, what's the best in Britain. You know, it's all about showing what we can do, and hopefully we'll get some good interest on the stand over the 2 days. We're really looking forward to it.
Yeah, and I can promise we will be doing live demonstrations. We have never done a show where the printers aren't actually making production parts, because there's no demo mode.
Right.
It's just going straight into production. We will be making parts at the show so people can see the exact speeds of what they can expect. No wool over the eyes. No, oh, we've sped it up just for the show. No, it's going to be making production, and it's going to be on the AM Futures stand, and we're going to launch it there and then.
Super. Okay, well, it just leaves me to say thank you so much to both of you, Jacob Lord and Nigel Robinson, representing Construct 3D and this amazing, you know, 3D printing technology that will be at Advanced Engineering, as you both say. Thank you, everybody, for watching and listening. Do register to come and see what they're doing on the well, the show is on the 29th and 30th of October at the NEC Birmingham. So we look forward to seeing you there. Just go to advancedengineeringuk.com and it's free to register and get your badge. Thanks, everybody. See you soon. Take care and good luck. Goodbye.
Thank you.